Hi, we're going to start with section 7.1, talking about secret codes, which you'll find out what that means when you come to class tomorrow. So this chapter is going to start by talking about input versus output, and I have an example for you. My example is about sheet music, and when you take music and you play notes on different instruments. So I would call the sheet music the input. It's what you're thinking about. It's the note that you're supposed to play, and then the output is the note that's actually played. So when you think about a piano, any of you who take music classes know that one key represents one note. So if you see the note on the page, then you play one specific spot on the piano. Whereas on a guitar, it's the opposite. There's a note maybe on this sheet music, but there are various ways that it can be played on the guitar. So I guess it's not really the opposite. It's just the fact that there's not one specific spot to play the note on the guitar. So it'll still sound the same, but there are different ways that you can get that. So there's different places on the neck of the guitar where you can play to get the same note. So that idea comes into play in math when we talk about the difference between a relation and a function. Here's our vocabulary. A relation is just any relationship between two variables. So the relation from the sheet music to the notes. However, a function is a little different. It's a specific type of relationship when every x value or every input has only one y value that goes with it. So domain and range are also some terms that you've heard before. Domain is kind of that input, that's usually our x values, and the range are the y values or the output. So go ahead and take a second to pause the video here if you need to, just to get these vocabulary words copied down on your note sheet. All right, now that you've got that done, I've got some examples for you. So we're going to look at two different tables and decide whether we think that that relationship between those two variables represent a function. Then we're going to also identify the domain and range of each relation. So if you look at Table A has three different numbers for the input, 1, 2, and 3, and I've identified that here where I see it says domain, 1, 2, 3. And output is the range, 2, 4, and 6. And if I look at my numbers here, see if I can get up my tools. There we go. Input 1 gives you an output of 2. An input of 2 gets you an output of 4, and an input of 3 gives you an output of 6. So every single x has exactly one y that goes with it, which is why that example is a function. Now you look at Table B, our second example, and this one, as you can see, is not a function. So that's because if I put in a 1 for my input, a 1 could give me a 1 for my output, or a 1 might give me a 5 for my output. Because there are two different y's or outputs for the same number in the input, a 1, that cannot possibly be a function. So we've got only a 0 and a 1 in the domain, and we've got a 1, 2, and a 5 in the range, which is also another indicator because there's not enough y's to match up with x's. So that means that, you know, a 1 and a 5, two numbers have to go with the same input. So a 1 and a 5 in the range match up with a 1 in the domain, which is why that's not a function. So I would like you to try this before you come to class tomorrow. I've got Table C down here. It should be in your note sheet. You can go ahead and decide if you think it's a function or not, and identify the domain and the range before you come to class tomorrow. Thanks.